Today we're going to work on logarithms. I know that may be something that some of you haven't had before. Logarithms are basically a different way of writing exponential equations. Right now I have the exponential equation 4 squared equals 16, and we can rewrite that as a logarithm. Now the reason why we rewrite it as a logarithm, later on we will get to equations where we have to have a variable in the exponent and we have to solve for that variable, and logarithms is one of the ways that we can solve those types of equations. So we need to understand what logarithms are. Logarithms can be rewritten. I can take 4 squared equals 16 and I can rewrite it. Logarithms have a base number. It's a subscript. It's a very small print number at the base of the word log. And your exponent goes on the other side of the equation. 4 squared equals 16. You may be able to tell better when you look at the print in your book, but you have a base number here, subscript. This number is called the argument number, and that's equal to 16. When you look at logarithms, you can sort of think of this as moving from one side of the equation to the other. 4 to the second power equals 16. Whenever you change from logarithms to exponential form, that's what we're going to use to change it. So if I had log base 2 of 8 equals 3, and I wanted to change it from its logarithmic form with the word log in it to exponential form, that gets rid of the logarithm. I start here with my base number, base of 2, raised to the third power, remember the exponent's over here on the other side, equals 8. 2 cubed equals 8. You can have variables in any of those locations, or you can have expressions. So if I have something like log base 2 of x minus 5 equals 4. A logarithm always has two things connected with it. You have this base number, this is read log base 2 of x minus 5 equals 4. You have this base number and you have this quantity. When you rearrange equations, you add, subtract, multiply, or divide, keep in mind that these two things, these two parts, stay connected with the logarithm. The only way to move those is to change it to its exponential form. So if I wanted to work this equation, and it's one where I could solve for x, I'd start out first of all by changing it to its exponential form and say that 2 to the 4th power base, exponent on the other side, equals x minus 5. Now I've changed it to a type of equation we're familiar with how to work with. 16 equals x minus 5. 2 to the 4th is 16. To solve for x, then all I have to do is add 5 and I get x equals 21. So that's the solution for this equation. And that's how you change logarithms to exponents and vice versa.